Hi, and welcome back to Hydroponics Daily. It's Friday, it's the weekend. In the UK, it's a bank holiday. I'm sat here, we've just cracked open some ciders in the office. It's an 8.2%, so it's pretty strong. Today's subject is going to be about speed breeding. So this is hydroponics that's used to increase the speed at which you can breed plants. So you may know that one of my big bugbears when it comes to hydroponics is the term used for indoor commercial hydroponics, and it's often called CEA, or Controlled Environment Agriculture. However, most of the crops, all of the crops grown in indoor hydroponics are horticultural. None of them are agricultural. Agricultural means things like cereals and maize and livestock and things like this. And you can't grow wheat hydroponically commercially. You can do it experimentally, and there have been a number of trials. NASA did a lot of work on breeding and growing wheat plants in hydroponics. They did it not in Florida or Texas, where you normally expect NASA to be doing their research. No, this particular NASA research was in Utah. Utah Saints. Do you remember that song from the 1990s? Utah Saints. It's where Salt Lake City is, isn't it? And in the early 80s, they did lots of research on growing. They bred a type of wheat that could be grown hydroponically, USU Apogee. Apogee is the name of a company that make light sensors as well, isn't it, I think? Anyway, it was dwarf, and it could flower a lot faster than normal wheat and get to harvest a lot early. So they did a lot of research, and then obviously other researchers have been progressing this since to find out the optimum growth conditions for growing wheat. They're fairly standard though. I mean, 21 to 23 degrees Celsius, that's normal for most crops in hydroponics. A light level of 510 to 930 micromoles per meter squared per second. That's, if you know light levels, that's pretty standard as well. That's not massively high or massively low. And 1000 to 1200 ppm of CO2, which again, that's standard for the optimum for many plant growing. So 21 to 23 at the day, 18 to 20 at night. And so that they developed new lines of wheat, and they looked obviously for space travel and things like that. But wheat research has continued, and hydroponics has been a key part of that. And part of that is speed breeding. And this can be applied to other crops. So if you're not interested in wheat, you don't need to turn off. But basically, when it's an annual plant like wheat or any other type of cereal, you normally have one stab doing a cross and growing that cross to see what it results in your field and your experimental station. And then you can double that up if you have another experimental station in the Southern Hemisphere. So a lot of research organizations have partnerships in New Zealand, South Africa, Argentina, places like this, Australia. And you can grow your wheat in the Northern Hemisphere, take the seeds, grow them down in the Southern Hemisphere, and vice versa. And that halves the time it takes to produce inbred lines and go through the number of cycles it requires to produce a whole new variety of any plant. So that's what's conventionally happens. So that the big breeders will have a research station down in the Southern Hemisphere, and the smaller ones will only do one. Obviously, with perennial crops, that's not the case, and you just have to grow them for years and years and years and then cross them when they're mature. So breeding apples is very difficult and doesn't normally involve inbred lines. But with hydroponics, you can get a number of different crops per year. So you're going from 1 potentially to 4 to 6. So that massively speeds up the amount of crosses and you can do. Now, we're not going into the details of breeding and how you do it in this episode, just to the rationale of using hydroponics. Now, obviously, the wheat or any crop you're growing hydroponically will not react in the same way as it will in the field. So that's something important to consider. Now, wheat in a hydroponic system will grow completely different as it will outdoors. And same for any crop. If you grow buddleias hydroponically, buddleia is an ornamental plant, without any UV light, it produces massive leaves. But if you grow outdoors, it produces fairly normal, fairly small leaves. And that's because indoors is completely different. So you couldn't breed for a feature about like architecture or even yield, really. It would really be breeding to breed in a feature that was not going to be influenced by the location. So it could be an active ingredient, it could be a protein content, it could be, something that's not going to change between growing it hydroponically and indoors and growing it outdoors. So you'd have to pick a feature, a trait that suited that and wasn't going to be upset by breeding some of the cycles in an indoor grow environment. It's still going to take a long time to grow these plants indoors, and wheat has a very long time. It has to senesce and dry out and things like this. So it's still not fast, but there are a number of research organizations that are now using hydroponics to breed wheat with this speed breeding. Could be a feature more in the future with genetic selection. If you can select a trait from just analyzing the genes in the plants, then and how they're expressed, then you don't actually have to see the trait appear. So it could be you have a genetic trait for yield or for disease resistance, and you're just checking that that's appeared in the new plants. So you might do this with like tomatoes. You might have a gene in a wild type plant that is related to an antioxidant in the tomato fruit, or it might be a color or a texture or ability to withstand transportation without going moldy and things like this. And rather than doing the experiment to find out whether it withstands transportation and stuff like that, you can just see if the gene is expressed when you've crossed it into the other variety. So with this technique, you can get a variety of wheat or any other annual plant in 6 to 7 years, which seems like a long time. But for a true new variety, this isn't a long time. That's a short period of time. You're talking 15, 20 years normally. That's why in some perennial or long-living plants that are dioecious, plants that are self-incompatible, you'll often hear, rather than saying a variety, they might talk about strains, because they're not true breeding. They've not been inbred. They're not F1 hybrids and things like this. So that's why you often hear the word strain in certain crops rather than variety. Cultivar is another term that you'll see. That just means cultivated variety. It's a portmanteau. Is that the word? They love them in horticulture. Sticking two words together: polytunnel, polythene tunnel, string trimmer. There's loads of them. I had a whole list of them once. So yeah, that's a diversion. Anyway, so that's been Hydroponics Daily for today. Speed breeding with hydroponics. Obviously, you can't grow wheat commercially with hydroponics, but you can speed breed it. And you could then, have massive inputs and increases in field grown cereals, which is what we need if we're going to feed an ever increasing population. So that's been Hydroponics Daily for today. As I say, if you're interested in anything, you want to get in touch with us, please send me an email. You'll find us on the Utrema website, as Utrema is Latin for wasabi. You'll also find lots of different biostimulants like tricontanol, humic acid, seaweed, and liquid gold, as we sell it in the UK, and in America, gold leaf. Until tomorrow, I don't know what I'm going to talk about tomorrow, but I'm probably going to record it now. I'm going to do some batch recordings, which will be interesting. Thank you very much for listening. Goodbye.